Welcome to this class on location and site selection. So we're dealing with the last elements of our project investment, and specifically we're dealing with the implementation part of the technical analysis. So today we will go through this outline starting from some general considerations about the definition of location and site, and some preliminary ideas on how to deal with the optimization of the choice. Then we will proceed with the location selection criteria and issues, and we will end this presentation by examining the site selection issues. So what is important to consider from the beginning is the fact that although they are sometimes used as synonymous, location and site refer to different aspects of project implementation. So as we will see, location will refer to a general consideration of the area where we are intended to establish the plant, whereas the site is the specific identified perimeter to develop the activities. Let's start with the general considerations. Location and site selection. What are the three most important business decisions? Location, location, and location. This adage is probably an overstatement of the importance of location, but there is no doubt that in a globalized world, the decisions about location are crucial both for offshore activities and for overseas investments. So mostly for companies and organizations dealing with geographical diversifications, the exact choice of location should be done according to specific criteria, as we will see, and in order to optimize the allocation of resources of the project itself. Location and site, let's see with some definitions. Location, in what country, region, town, village should the plant be located? Whereas site is where in the town, village, or region should the plant be constructed. So as we were anticipating, location has a more general meaning than the site itself. So with the term location, we refer to the geographic distribution of activities. Where we deal with the site, we're deciding where exactly to establish our plans and how to run our activities. Location selection criteria and issues. As we will see, we will have different criteria and different related issues related to the selection of the optimal location. So, generally speaking, the criteria are meant to rate different elements of which are important for the location choice. And specifically, we might refer to different elements for multi-criteria location analysis, such as production factors. So we have to deal with different efficiency conditions from urban areas to rural areas. So when it comes to urban areas, we might benefit from the existing established infrastructures, whereas when it comes to rural areas, there will be a higher chance of expansion for the company's activities. Site requirements in terms of strategical location of the activities, being closer to the markets or being closer to the ports or the harbors might reduce on the hands costs on one hand and incomes or revenues on the other hand. Infrastructures and markets and suppliers are both very important. So When it comes to infrastructures, we've seen already that we are dealing with both physical and social infrastructures, whereas when we deal with the markets and suppliers, we're considering the other organizations playing different roles within the same competitive arena of our project. Then we have other strategic factors like the proper consideration of the risk embedded in the company's activities, and then we have other cost and risk factors like additional and ancillary resources that we need in order to choose and establish the plant in a specific location. So when it comes to multi-criteria location analysis, that implies that the optimization of the choice will be based on different elements. Just to give you an example, we might have, as depicted in this table, a different criterion of choice, namely production factor, site available, infrastructure, markets, and a total of n different factors that we take in consideration. And then we might assign a weight to all these factors for both locations, location 1 and location 2, in case we're choosing between two different locations. If we have m different locations, then we have a matrix of m locations and n factors. For each location, we will end up with a total location points score, which means that considering the weight of each factor, let's say on a scale, as we will see, from 1 to 5 in terms of importance for the location, and the presence of such production factor in this specific location, ranging, for example, from 1 to 10, then we'll have a total point location related here, which will be helping the company choose between location 1 and location 2. So when it comes to multi-criteria optimization, to be more specific, we have a numerical weight scale which is selected and assigned to each criterion. And then we have a location point scale which is selected, and each location is scored for the criterion. And we have the highest point total, which indicates the most favorable location. So by comparing two or more locations, one with the other, we might be able to find out what is the optimization of our function. In formulas, we have that Tp K equals to the sum of Wj times Pjk for K ranging from 1 to m. So let's assume that weight J is the weight for the criterion J, and that Pjk is the point for criterion J and location K. So, as we were mentioning through the table, we have K indicating the specific location for a number of alternatives of different locations spanning from 1 to m. And then we have J in terms of criterion which is selected both in terms of weight and in terms of point for that specific location K and that specific criterion J. So the idea is to optimize the total points. So the facility gaining the higher score is going to be chosen as first, and then we could have a different classification and different ranking of the different facilities according to the TPK scores. That's for the assessment of the importance of the presence of different criterion on specific location. Another way for estimating the importance of the location, the priority to be assigned to the location, is to consider the geographic distribution of the actors. So we might have this location triangle, or in case of imports and exports, we might refer to a location quadrangle, and so on. So let's have a look at the actors depicted here. We have suppliers, supplier number 1, and then till supplier number n. Then we have the factory. So the company, through the project, is buying raw materials and services from the suppliers, as we've seen already. So we have this inflow of materials and services coming from the suppliers to the factory. And then we have the factory sending and delivering its products to the market or to the port for further distribution. So here the idea is that we have volumes of materials and products, and the exigencies of transportation between the suppliers and the factory on one hand, and the factory and the clients on the market, or to foreign customers through the ports, and similar other actors. So we have distance here, we have transportation exigencies here, and then we have transportation costs as well. So one way to choose the location here, where to locate the factory, is to minimize at the least cost the total transportation costs, which means that we determine the least cost alternative and then we choose it. In formula, we have that the planned location minimum transport cost might be determined this way. So let's consider K as the location that we choose after the analysis. And we choose the location which is equal to the minimum of this function. So let's consider these elements, K, R, and D. D is the distance, K is the unit transport cost, and R is the quantity transported. And J, spanning from 1 to n, is the subscripts for individual suppliers, so the inflow, and customers at fixed locations, so it's the outflow. So considering this equation here, we have unit transport cost times the volume, which is the total transport cost, times the distance to be covered. So the location which is going to be chosen, K, is the one minimizing all the different transportation costs related to the interaction with each actor, both in the inbound and outbound side. Graphically, location analysis transportation costs could be depicted this way. So we have again suppliers and customers being characterized by K and R, which means a unit transportation cost and a volume to be moved. And D1, D2, D3, Dn stands for the distances between all these elements. So the optimum planned location, it's a kind of center of gravity. It's like in physics, it's a force table in a physical laboratory. So the equilibrium should be found and the location should be chosen according to the fact that this location is able to become the center of gravity in terms of minimization of the transportation cost. Of course, all these elements might be driven by considering the specific characteristics of the industry where we are operating. So, according to the industry, we might have different scenarios. So, project location preferences might be labeled as raw materials oriented, which means that the product and the project is moving in a direction which is closer to the sourcing of raw materials rather than to the market. This is very typical for petroleum, for agriculture, for example. So to be specific, we have the mining project, since we want to be close to the mine, to the natural source of our materials. Hydropower, where we have to be closer to the hydro sources, and agro-industry. So getting closer to the fields could enhance the yield of the exploitation of the land as well. Another element of this project allocation preferences is about the market orientation. So instead of getting closer to the raw material sources, as in the previous case, the project is located closer to the markets, which is very important for services. So mostly for services which are meant to be delivered to individuals on a face-to-face contact between the company and the customers, is crucial to get this market orientation. So services, high-quality garments, the exposure of products is crucial for luxury and fashion, for example. Water-based beverages, getting closer to the market could enhance the perceived quality of the beverage itself. And then we might have the combination of different orientations. So we might have within the project location preferences the flexible location, which happens for machine tools, electronics, and pharmaceuticals. So we have a combination of some parts of the company and the project being located closer to the raw materials and some other parts of the company being established closer to the markets. So when it comes to location, which is the geographic area to be chosen, as we've seen, we have different criteria of optimization and different issues related to the specific industry and to the different exigencies of the project itself. When it comes to the site selection issues, we have additional elements that we should take in consideration, and as we will see, these elements lead or potentially could lead to additional costs or to the increase of the revenue power of the company itself. So let's consider some site selection issues. Site selection considerations could be made about the preliminary facilities layout. So when it comes to preliminary facilities layout, size and shape of the area are very important. So when it comes to the configuration of the plant, when it comes to the positioning of the plant and the opportunity to deliver the products, the size and the shape of the area being accessible or less accessible is crucial for the project itself. It's not just the shape of the area, but it's also the allocation for buildings and main equipment. So it's not only the site itself, it's also the surrounding area making it possible to establish some economic activities. Being a little bit more specific, we should plan not only the facility as we've seen already, but also we should plan for rods, rails, conveyors, and other utilities. So as we've seen already in the class dedicated to the plant capacity, and to the plant installation, the consideration of the surrounding physical infrastructures is crucial for the plant final installation and in a preliminary phase for the choice of the site itself. Storage areas for materials and products. So we've seen already that in order to establish the economic activities, we need to store some raw materials on one hand or semi-products, and as well as some final products. So space for storage areas is crucial too. Another element is the consideration of the environmental sensitivity of the area. So as we will see during next class, the environmental analysis is another important phase of the selection of location and the site. Office and service buildings and areas. So it's not only the location of the specific operation related activities like manufacturing, maintenance, but it's also activities related to the administrative and support part of the value chain. So space of office and service buildings is very important too. Again, environmentally sensitive areas might be considered, and the opportunity of future expansion. So when it comes to the expansion, we've seen already that the urban areas might be better in terms of infrastructures, but may be more limiting for the company in terms of future expansions, whereas rural areas might give the company higher opportunities or better opportunities for future expansion. Nevertheless, we should consider the wetlands, natural habitats, and of the endangered species, for example. So if we have an endangered species, we should consider the preservation of the natural environment too. But about these aspects, we will say something more during next class. So these are the main elements considering the issues for the site selection and installation process. Also about the selection considerations, we might have the basis for the estimating. So we have the cost of land in terms of acre, hectare, things like that. Building and civil works. So the site engineering, for example, is included in this activity. The outdoor works, in terms of utilities, so proximity to the sources, access to the infrastructures, things like that. Operating costs for in-plant transport and communications. So this is very important too. I mean, as the size of the plant expands, the communication and the internal transportation of raw materials and semi-products becomes more complex. So it's not only the distance separating two or more points, it's also the complexity of dealing with an internal transportation system. So the operating costs for in-plant transport and communications, as we've seen already during the classes dedicated to the installation of the facilities, could be a very important and relevant part of the site selection. So at the end, the site will be chosen not only for the physical space which is needed in the beginning of the project, but it's going to be chosen also in consideration of the scenarios considering future expansions too. Again, the site selection procedure describes process requirements. So, geographical factors are very relevant in this phase as well. So, for example, the use of the natural gravity. It's very important for the layout of the plant and the choice of the site as well. So by exploiting the natural gravity, company will be able, for example, to let some liquids flow from uphill to downhill without using any additional energy. So having such an holographic distribution of the activities, companies might be able to save some costs when it comes to the industrial production. In terms of selection procedure, it's very important to determine preliminary selection criteria. So the determination of the infrastructure requirements, of the capacity and size, is crucial for the selection of the site. So what we said about the plant capacity, it's very relevant for the site selection as well. So as we've seen already, the plant capacity could be determined in terms of the scale that the company is expecting to gain in order to reach, in order to manufacture some products and to sell some products in the most efficient and effective way. So if we choose for a whole integrated plan rather than for the distribution of smaller plants in a geographic area, it's a crucial choice in terms of site selection too. So all these elements that comes from the sales program and the production program and the plant capacity program should be considered too in terms of site selection. So they might be included in the criteria. The third element it's the identification of priorities. So similarly to the location selection, also for the site location, we might have different criterions, and we might rate this different criterion according to a scale spanning from 1 to 10, for example. So by considering all these elements that we find important for the site selection, we might be able to identify priorities by weighting the different factors with a specific weight. At the end, we might be able to identify alternative sites. So when it comes to the different scenarios for the site selection, we might go through this procedure, which embeds the development of preliminary facility layouts. So, if we consider the same site, we might consider different possible layouts to be implemented in each site. And of course, the economic analysis could help us define the most efficient or most effective distribution of resources in the site. At the same time, we might consider the same layout in different possible sites. So if we have some constraints given by the technology they were choosing or given by the production standards that we're referring to, if we have some standards to follow for the site and the plant, we might consider the simulation of the installation of an hypothetical plant on a specific site, considering different sites at the same time. Estimate differential costs of site preparation and operations. So, if we have different sites to be compared, again, the economic analysis could help us in terms of differential impact of the different choices on the economics of the project itself. So, how can we conduct a differential analysis? Well, if you have different sites to compare, we estimate all the elements for one site, and then we consider this site, let's say A, as a benchmark for estimating all the costs and the impacts and the resource absorptions for the other sites. So the differential analysis is intended in the way that we fix one plant or one site, and then we compare the differential costs and differential resources which are absorbed by the other sites. If we base our final choice on a multi-criteria analysis, similarly to the location choice, we might have a table with different criterions again, and we state some weights for each criterion in terms of importance, and then we might assess the different locations, the different sites in this case, according to the presence of such an element on this specific location. So similarly to what we have done in many other classes, we are going to end up by considering a list of elements to be considered and a field of possible applications. So again, the methodology for the implementation of this part is exactly the same that we always followed. We consider the list of our priorities or the checklist of what has to be done in order to implement the project, and then we have the field of application, the internal environment of application, the domain of application. So, materials and service items. So the site is absorbing resources, it's absorbing investments in terms of materials and service related aspects. So since we are estimating the cost of the civil engineering works, civil engineering is closely related to the exigencies of our suppliers in terms of the possibility to deliver materials and services. Then we have to code all these exigencies, and what is most important, we should assess the quantities. So we should figure out in terms of inbound logistics what the company needs in terms of materials and services, and according to the exigencies in terms of qualitative items and the quantities related to each item, again, the project should be able to optimize the consumption of such resources by establishing the site and by referring to the civil engineering works in terms of optimal location. Again, we need to consider the unit costs for each element, so it's just the kind of answer of the company to the pressures from the external environment. And we have to consider the difference between local and foreign exchange. So, by being conducted in one area, so everything is embedded in the same geographic area, or by being spread in different countries, the costs might differ both in terms of transportation costs and in terms of exchange rate of the currency as well. Considering all these items, we might be able to sum up the analysis with the total cost. So far we have considered that the selection of the location and the sites are influenced by all these elements that we've seen, and they're trying to optimize the resource allocation by the project itself, which in the end is by the organization. Total cost, which is just the sum of all the items we have considered. So, consider that we have different sites meant as different alternatives. By comparing different costs of the different alternatives, the company should be able to optimize the the site selection too. If we move further and we consider the application of such a checklist to the different domains, we will encounter different situations. So, again, the estimate of site investment costs for civil engineering works applies to the site preparation and development. Now, this phase is crucial if we consider that we classify the investments both as greenfield and brownfield. And the distinction between greenfield and brownfield is the fact that on the previous case, the company should take care of the site preparation as well from ground zero hypothesis, whereas in the brownfield, the company could exploit some pre-existing infrastructures. So in both cases, both greenfield and brownfield, a preparation is necessary. So the preliminary activities of preparing the land and preparing and excavating, for example, the physical space is required. It's not only the installation of the plant, but it's also the development of the plant itself and of the area. So once the building has been built and the plant has been established, then the company should consider the development both of the physical capacity of the plant and the development of the area as well. The central part of all the engineering is about buildings and civil works. So this is the core part of the construction plan. So in terms of impact on the site, in terms of development of the sites themselves, buildings and civil works are required both for the facility and for the surrounding infrastructures. Outdoor works are also required. So we're recording the idea here that the facility is installed into an existing area of infrastructure. So sometimes the community and the social representatives of the government ask the company to realize a part of the infrastructure as well. This goes for the waste, goes for the steam, goes for water and things like that. So if we consider all these situations here depicted and we consider the list of elements helping us define the total cost of the site installation, it might be evident that we have different scenarios and different elements of costs that should be included in the investment plan as well. So today we have dealt basically with the issues and the aspects related to location and sites. We've seen that location and site may differ in terms of terminology, but also in terms of very practical implications. And we have acquired familiarity with the fact that in each case, optimization is the main word. So that's everything for today. As usual, you might find additional information and additional resources for the future deepening on our website. Thank you.